All right, moving right along, guys. We're going to get into some domestic hot water. Let's see what we got here. No, I don't want to do that. We'll figure this out eventually. How do I get that dot off of there? Okay. This is a heat timer ETV, or electric tempering valve. This is the Abilene standard. This is what you guys are seeing. We're prefabricating these in the shop, and more than likely you're not putting them together on a job, but I would like you to understand what goes into them and some of the small points. First of all, every valve, hot, cold, and mixed water, is full port ball valve. Now there's two different types of ball valves, full port and it's a reduced port. Full port ball valve on all domestic water. Basically, when you look inside the valve, you see a clear straight line through. The regular ball valves have about an inch. If it's a 2-inch valve, it looks like an 1.25 inch opening. We use those on drains and on some steam lines, steam traps, things like that. You can use that. But for domestic water, we want full port so that we do not restrict the flow of the water as flowing through inside and restricting the flow to people's faucets up on top. You'll see as we go down on the left side, the cold water. Down at the bottom is another ball valve and a drain. That's for servicing. We like to have a low service. It's called actually a hose cock. All right, we get very sexual plumbing. And the hose cock is for servicing when we have to drain the water out. If you look a little closer going to the right, following the green arrow, there's a bracket that supports it to the wall. More important than that is the union. On each side of the apparatus, we have a union for servicing. Makes the serviceman's life easy. And we know we just like to make their lives easier. That's what we live for. We want the servicemen not to be inconvenienced. Was that a joke? We also have, if you look at the large face thermometers, that's also for servicing. We can tell if the temperature going up into the people's apartment. Let's follow the hot water coming through. The orange, that's where the thermometer and then the sensor are mounted on the outlet of the mixing valve, but you also have that large face thermometer. That thermometer should never read more than 140 degrees. And if it is, we have a problem and you need to report it or you need to fix it right away. Why that's a problem is because that temperature, that water goes up into the people's faucets, and there's kids, and I think we spoke about this in the past, showering underneath that. So if that water gets too hot, we can burn people. So we have to be vigilant. When these jobs are set up, when you're going back to do all your labeling and tags and arrows, that's when we do that at the end. Take a look at it. You'll see you'll have hot water coming in, usually around anywhere between 160 and 220 degrees, depending on if it's making steam or not. That's normal coming into the hot side. The hot side comes in on the bottom. That's the yellow pipe coming down on the bottom. Going out is always 140 or less. I actually like to put it down around 130, 135. If you put your hand under 140 degree hot water, it only takes 5 seconds before you get burned. All right, so that's still pretty hot. The green box on the top, which the electricians get into, I really don't know how to wire it, but that green box actually tells the control, which is this three-way valve. On the bottom you have hot, on the left side you have cold, and on the right side you have the blended water. The sensor tells the brain to move the stem up and down, regulating that flow according to the set point. We also have nice flow arrows. All right, you see that's our standard, the flow arrows and the labels, hot water, blended water, and cold water. Look up on top of the valve tags. We have hot water valve tags, and there's supposed to be one that says cold water and mixed water hanging in it, and it is there. It's just flipped around backwards when we took the picture. So this is just a standard Abilene mixing valve. Any questions on the ETV, the heat timer electronics mixing valve? Any questions at all? Anybody have anything that we want to go over on that one again? Good. I'll hit on it again in a little bit while.
Always make sure the circulator pump is working.
Getting to that one. You're jumping ahead of me. Hold on. No problem. No, we're not going there. We're going to go this way. All right, here we go. This is the instruction that comes, by the way, when we get these boxes and the mixing valve comes there, there's a whole bunch of papers inside them, and those papers are the instructions. Read them. I always see them on the floor. I'll pick them up. I'll put them into the electric panel, just so we have them. But that's the information that makes the pipe fitter into the foreman. That's the information that makes the electrical helper into the electrician. The stuff that comes packaged with this equipment is really manufacturer's recommendations for installation. You have to use it. And if you don't understand it, if you don't think it's important enough to read it, you're never going to advance. Get that information. I want you guys fighting over it. Matter of fact, I want you calling me up, say, give me 10 pieces of the heat timer ETV instruction booklet, because everybody wants to know. That's what we want to do. Let me just go over this quickly. It's really not a lot going on here. All right, this is a hot water. You see in the middle of the big square, that's the hot water source. More than likely, that's the domestic coil. It could be a hot water heater. That's where we turn the flame and transfer the heat of the flame into hot water. We have cold water coming in the source, and on the outlet side, it gets hot. Picks up the heat transfer and brings it out. Now we need to regulate it. That's why we put the mixing valve in. The mixing valve is the ETV. It's up on top, the three-way mixing valve. Important feature on the piping safety issue, one would be on your cold water, if you look right to the right of that little X is a symbol that symbolizes a check valve. That check valve is crucial to the system really for one main reason, okay? When you have your circulator pump that's running below it, and always run continuously, bring in the hot water back from the return, if that check valve is not there, the hot water can work its way back up into, imagine another riser right next to where that cold water arrow is, and that's someone's toilet bowl, and they're sitting on the toilet bowl, and they go to flush, and that check valve doesn't work, or it's not there. You get hot water running into the cold water fixtures. You get hot water into the toilets, you get hot water in, and you have all kinds of problems. It's also dangerous. It's not very comfortable, although maybe it is to have, when you're sitting on a toilet bowl, to have hot water underneath you, but I don't know if I really want to find out. Moving on, the next fitting, if you look going into the hot water heater, you have a 32-inch minimum vertical thermal heat loop, okay? What that means is you just simply bring a piece of pipe down, 32 inches below the center line of your heat source, which is typically the coil, and you go back up and you bring it in. And now, why that's important is you don't want the hot water backing out through gravity during low flow periods, back in and mixing in with the cold water side. And it'll be easy to understand when I get to the next slide. I also included in here important feature, especially for the electronic valve. We have an actuator with a manual override. So if we lose power and the ETV control is not working anymore, the electronic portion, we simply flip up the override, and we could set the temperature manually, at least temporarily, to give people hot water. All right, and then we try to get someone back right away to fix that. That's a cool feature, and you want to read these instructions. I don't want to go over each and every one. I gave you a full package of it so that we don't have to go line by line here. By the way, another important is the way to mount these heads. You see, you can mount them in 3 different locations. All right, you can mount them horizontally or vertically, but never upside down. The motor cannot be facing down. Another thing is, if you look, it shows you a cold port on the left, hot port on the bottom, and the mix port on the going out to the right. I believe when you set it, you have to push the stem down and then put the motor on it and to calibrate it. And if you want to learn how to calibrate it, read the instructions. All right, there's a way to do it. The calibration is just lining up the motor with the temperature. That's all you're doing. Any questions on this section? Okay, let's see if we can get this right. All right. This is another mixing valve that we use, and this is fading out, but it's still reliable. It's a good mixer, that's what Hobie says. It's fading away as we get more into the electronic age. There's a couple of differences in the Hobie than with the ETV. Really, the only difference is they require only a 27-inch thermal drop. You also have a continuous running circulator from the domestic hot water return. You have a check valve. You have thermometers. What's missing? Imagine this was an Abilene job. What's missing on this? What don't you see here that we normally do on every installation? Anybody? No, circulator pump's up there. Well, the bypass around the circulator, typically we'll put a new circulator off to the side with a 3-valve bypass. So that's something that's not on this drawing. What I was thinking about was the thermometers in the inlet and outlet of the coil. We always do that, and we do that for serviceability. It makes life easy for people that are servicing, and we understand if there's hot water coming out, if sometimes the coil doesn't produce properly, we know about it just by simply having thermometers. See on the right, relief valve on the bottom, that's very critical. The relief valve is sized for the temperature and the pressure. It's rated for the temperature and the pressure that's the pressure coming into the pipe. Another issue is that relief valve must be piped to within, I think it's 12 inches from the ground, inside of 18 inches to the ground, with no thread on the bottom of that pipe. Could be black or cast or copper, I'm sorry, but it can't have a thread on it. What type of material do we use on domestic water? Anybody? Brass or copper only, thank you. Why? Black pipe will corrode. Within a period of months, black pipe will deteriorate from the inside out, and it will send rust particles into the system. I think it's called non-ferrous material. Check valve on the cold water inlet. There's really only one instance where we don't need that. Can anybody tell me why there are sometimes we'll not need a check valve on the cold water coming out of the ceiling or coming into the boiler? Anybody? Vinny? Exactly. A lot of times in these high-rise buildings, we have a roof tank feeding the domestic water, express riser straight down to the boiler room. Usually you'll see the pipe coming out of the ceiling. It's usually 3-inch or larger in the bigger buildings. That pipe does not have any other takeoffs that are feeding to the tenant's apartments, but comes directly into the coil. In that case, putting a check valve on it really is just a waste of money, because there's no way that hot water during a low period can come out, go up 30 stories into the roof tank and mix with the domestic cold water. It's not happening. So, in some cases, we'll put them. I just want you to know why. I mean, if you do use it, it's a waste of money. That's one thing. It's not going to hurt the system, but we don't need to do it. So just try to understand why we put the check valve on the domestic cold water. Let me just see if there's anything else on this. I made some notes, but I pretty much have it. Down feed. Okay. One other thing is the copper type. Typically, we'll use type L copper. Copper is rated in three thicknesses, wall thicknesses. There's type M, which is considered soft tubing, type L, which is standard tubing, and type K, which is extra heavy. And that's just simply the wall thickness of the copper. Standard is type L. There are times we'll use type K. Usually the engineer specifies type K to give the building a better value for the job. I quite frankly don't think it's necessary on a lot of the lower rise buildings. There's not enough pressure to affect it at all. So we'll do that on a case-by-case basis only. Typically you'll see type L. How do you know if it's type L? It's marked, right? It's marked, it says type L. If you want to know an easy way to find out, the type L is yellow. Type K is green. Thank you. Thank you. Actually, I'm going to say blue first. He's right. It's blue. There's a blue stripe in it, and it says type L. If it's green, it's type K. It's a quick way to find out. Any questions on domestic water? And I just really went into the basics. I wanted to just give you sort of an intro. We can go into heat transfer and things like that later on. Anybody? Hangers and supports. Okay, I got another point, and I'll get to you. Hangers are very important in domestic water, especially You should use them the same as you use, we went over the hangers in the gas code. It's the same spacing requirements. Matter of fact, as the pipe gets thinner, it needs more because it's flexible. You don't want that pipe flopping around. A lot of times in large buildings, there's flushometers, and flushometers are the handles on the side of the toilet bowls. And they create a back pressure in the system. So if that pipe is loose and hanging around in the boiler room, it's not supported or clamped tight, you'll have leaks develop. On the joints, when we're soldering the joints, we're using silver solder pretty much across the board, it's silver bright soft solder. The code is 95.5, which means that it has to be at least 95%, only 5% lead, 95.5. 50/50 was in the old days. They eliminated that. I do believe that they're going to eliminate 95.5 too, because we're going to all no lead fixtures coming up, which is the new code. We're going to have no lead at all. So silver bright solder is what we're using on the solder joints. Okay, Vin.
I have a question. A lot of times I see us on a copper pipe, either soldering or brazing. Where do we use brazing?
Yes.
Solder.
We pretty much have a standard for that. When we get into the high-rise buildings and we're using 4-inch copper, 4-inch copper with solder joints don't last long. So we go into silver solder, which is a higher heat and a braze. It's almost like a welding. That will permanently keep that pipe together. When we get below 3-inch and below, we can go, in some cases, I'll even go with 3-inch brazing if I have 125 PSI or more. But most of the time, we'll stay with silver bright solder on everything else. Does that answer your question?
So it depends on the height of the building?
It's the pressure involved and the pipe size. The bigger the pipe, the harder it is to get it to solder. And even if we get the solder to hold, 6 months later, invariable, we'll come back and there'll be leaks. So we just sort of decided, the same way we decided years ago to stop screwing 4-inch gas pipe. And we're welding everything now because it does leak over time. It's just a better practice. And we like to do things once if we can. Let me see if I didn't cover everything here, guys. This is a 2-pipe system. And again, this is the Holby. This is the same as a 1-pipe system. There's 2 things, and this is for Misha, I wish he was here, that we want to be aware of. First of all, the T-takeoff for the cold water is always before the coil. I don't know if you can follow the cold water line coming in the center. It's always before the pipe goes through the coil. More importantly, and it's not on this drawing, but we put check valves on each outlet going into the hot water side. And here's something that Misha discovered over time, is if you can balance the T, center the takeoffs exactly, a lot of times you won't get the draw. And here's a problem that we run into a lot. When we have one boiler off and the other one on, and I'm going to have to step closer here to get a view. Let's say this boiler is off, that boiler is on. The cold water will flow through the coil, go into the boiler, and come out. And if this boiler is cold, it will come out cold water, and it will actually mix with the hot water coming in on this side, and it messes up the temperature. The building can have problems, run out of water. But we find if we center the T's exactly, the hot water and the cold water between the boilers, those T's that take off to the inch, it balances itself out. When one boiler is off, you don't have to shut the isolation valve. The super doesn't have to shut the isolation valve in a lead lag situation. So that helps a lot. So just try to focus on that, and you've been doing that, right? That's what we're doing now on the double boiler jobs. Any questions on a 2-pipe Holby? Nothing? You guys are experts already. That's cool.